It lasted nearly a full day and repeated in bursts like a cosmic heartbeat. Named GRB 250702BDE, it's the first of its kind in 50 years of observations, and scientists are still searching for answers. In this video, we'll explore how scientists uncovered its unusual repeating pattern, what it could reveal about black holes, and why this burst is rewriting the rules of cosmic explosions. Gamma-ray bursts, or GRBS, are usually dramatic but short-lived. They mark some of the most violent events in the cosmos, whether the collapse of massive stars or the collision of compact objects like neutron stars. But GRB 250702BDE broke every expectation. On July 2, 2025, Fermi registered a high-energy outburst unlike the usual spike and fade profile. Hours earlier, the Einstein probe had already caught activity, extending the timeline back nearly a full day. Instead of a singular catastrophic event, astronomers saw multiple episodes of emission, separated in time, yet all coming from the same location in the sky. At first, there was uncertainty about whether the source lay within our galaxy. The burst seemed unusually close and bright, raising the possibility of a rare galactic transient. However, observations with the Very Large Telescope provided crucial evidence. The afterglow pointed to a host galaxy far beyond the Milky Way. The Hubble Space Telescope later confirmed this extragalactic origin. This discovery elevated the burst into a new class. Ultra-long GRBs have been observed before, lasting hours instead of minutes, but none with this level of repetition. The pattern suggested not just a one-off collapse, but some kind of system that could sustain multiple, powerful releases of energy. The data showed 3 main peaks of gamma emission, each separated by several hours, with hints of smaller fluctuations in between. This structure pointed to a central engine that did not shut down after its initial explosion, but somehow kept reigniting. For the first time, astronomers had evidence of a gamma-ray burst behaving more like a cycle than a single terminal event. The burst's brightness and endurance were staggering, far beyond most known explosions. The big question for scientists now is simple. What engine could power it? Several explanations have been put forward, each stretching existing models. The first involves a massive star collapse. Normally, when a giant star, perhaps 40 times the sun's mass, dies, its core collapses into a black hole and launches a jet of gamma rays. The event should be singular because the star does not survive. But if enough material falls back onto it in stages, it could trigger repeated outbursts. This fallback accretion model might explain the timing gaps between the bursts. Yet, such sustained and powerful repetition has never been confirmed in real data, making this scenario difficult to reconcile with current theory. Another candidate is a tidal disruption event. Here, a star wanders too close to it and gets shredded by its gravity. The infalling debris fuels bright emissions. But in most cases, the light curve of a TDE shows a gradual decline, not sharp repeated bursts. To explain GRB 250702BDE, it would need to consume the star's material in pulses, almost rhythmically. That suggests an unusual kind of it, one in the middleweight category known as an intermediate mass IT. These black holes, thought to range from a few hundred to a few 100,000 times the sun's mass, are the missing link between stellar mass and supermassive black holes. Theoretically, they form through mergers of smaller ones, eventually seeding the giants we find at galactic centers. Yet, firm observational evidence for their existence has been scarce. If it is indeed powered by such an object, it could be one of the strongest clues yet. Some suggest a magnetar or unstable jets, but only precise measurements of the burst distance, host galaxy, and energy will reveal the true cause. The significance of GRB 250702BDE goes beyond just one unusual event. It forces astrophysicists to rethink how gamma-ray bursts are classified and what mechanisms drive them. If this event is tied to an intermediate mass black hole, it could fill one of the biggest gaps in astrophysics, proving the existence of a population of them that bridges the size spectrum. Finding them would confirm theories about how they grow, and by extension, how galaxies evolve over cosmic time. Even if the explanation lies elsewhere, the burst reveals that the diversity of GRBS is broader than previously believed. For decades, the classification system has revolved around short and long bursts, but it doesn't fit neatly into either category. It may signal the need for a new subclass, repeating ultra-long bursts. The event also underscores the importance of multi-instrument astronomy. Without the combined efforts of Fermi, the Einstein probe, ESO's Very Large Telescope, and Hubble, much of the picture would have been missed. This kind of global cooperation will be critical for future discoveries, as rare and fleeting events like GRB 250702BDE require quick, coordinated responses across the spectrum of light. Looking ahead, astronomers are working to pinpoint the event's exact location and measure its redshift. This will determine how far away it is, and in turn, how much energy was truly released. They are also monitoring the afterglow across different wavelengths, searching for signatures that could reveal whether a black hole, magnetar, or some other engine was responsible. Meanwhile, theorists are running detailed simulations to see if known processes, fallback accretion, jet oscillations, or tidal shredding, can reproduce the observed data. Others are scanning archival records to see if weaker or shorter examples of this phenomenon were overlooked in the past. It is a reminder that cosmic surprises aren't errors, but opportunities to challenge models and expand our understanding of the universe. ERB 250702 BDE lasted nearly a day, repeating in ways no gamma-ray burst ever has. Whether it's a massive star's death, a black hole's signature, or something stranger, it's reshaping how we see cosmic explosions. The universe still holds mysteries, and we'll be here to explore them. Subscribe for more discoveries beyond the edge of science.